Natalie, thanks for sending your question. I'm not sure whether this is a plus or a minus in here, but since this guy's a plus over here, I'm going to give you your solution on the basis that this is indeed the term that we're working with. So let's go ahead and get started. Doing a partial fraction decomposition is based on the idea of a least common denominator. So let's look at the right-hand side of this equation. If these were fractions that we were just adding, we would first have to get a least common denominator to do it. So let's start there. So this is all equal to a over 3x plus 1, or a times 3x plus 1, over x plus 1 times 3x plus 1, plus b times x plus 1 over 3x plus 1 times x plus 1, and that of course is equal to the original left-hand side of the equation. So all I've done so far is multiply on the top and bottom by the factors I needed to get my LCD. Let's go ahead and now simplify the right-hand side of this equation. So if I distribute a and b, on the top, I'm going to get 3a times x plus a plus bx plus b. And on the bottom, I'm going to get my least common denominator. Since both of these guys are united by the same common denominator, I can just go ahead and put them over the same denominator. So if you look at the left-hand side and the right-hand side of this equation, they now have the same exact denominator. For the purposes of our computations, we can just go ahead and pretend like that denominator isn't even there. So let's take the numerators of both the left-hand side and the right-hand side of our equation and set them equal. So 3ax plus a plus bx plus b is equal to 1. Now we're going to group like terms, and by like terms I mean x's and not x's. So 3a times x plus bx plus a plus b is equal to 1. Let's go ahead and factor out an x, and we'll get 3a plus b times x plus a plus b is equal to 1. I'm going to go ahead and reflect how many x's are on the right-hand side of this expression right here. Because what we're going to do is we're going to take the left-hand side and the right-hand side and we're going to start matching them up. So I'm going to match up my x's and I'm going to put an equal sign in between them. So 3a plus b times x is equal to 0x. And let's match up the not x's. A plus b is equal to 1. What this means is that I have a system of linear equations where I can now solve for these two variables. Let's go ahead and get rid of the x's here, and we'll see what we're working with. So 3a plus b is equal to 0, and a plus b is equal to 1. You can solve this using whatever method you choose. I'm going to use elimination. I'm going to multiply the second equation by -1 so that I get the system 3a plus b is equal to 0 and -a minus b is equal to -1. Let's go ahead and add down to eliminate our b term. 3a minus a is 2a. 0 minus 1 is equal to -1. We can now solve for a. A is equal to -1/2. Let's go ahead and substitute this back into whatever equation is easiest. I'm going to choose the second one. So if a is -1/2, that means -1/2 plus b is equal to 1. Which means b is equal to 3/2. So I've now solved for a and b. Let's put it all back together. if a is negative 1/2, then negative 1 over 2 times x plus 1 plus b is 3/2, so 3 over 2 times 3x plus 1 is what I will get when I do my complete partial fraction decomposition, and this will be your final answer for your question. Thanks again for your question, Natalie, and I look forward to answering more of your questions using SnapMath in the future.